It's absolutely wonderful to see so many people here today. So I want with you today to delve into the intricacies of the Prone Meteor. Now there's a photo of it here, and it looks, until you get just forward of the main cockpit, it looks for all the world like a standard Gloster Meteor of the period. And in fact, these modifications were made on the last Gloster Meteor off the production line, FK935. And you can see that a rather long nose has been added there with its own little cockpit and some poor sod lying face down in that cockpit trying to see out and fly the aeroplane. So here's the standard Gloster Meteor of that time. This one's in RAAF colours, and you can see two of the four 20mm cannons there at the front. The Meteor was a very rugged aircraft, which was just as well, I think, because the engines were so far out on the wings that a lot of them were lost with trainee pilots who lost an engine on the approach and applied full throttle to the other engine, and the thing did a gyration and landed, and they used to call it the meat box because it had a rather unfortunate habit of dispensing with trainee pilots. You may recall from the virtual talk that I gave a few months ago that I was very privileged to spend some time in the UK and volunteer at the Royal Air Force Museum, Cosford. And in fact, our first assignment there in the test and experimental hangar where we worked was working on the Prone Meteor. And here is the Prone Meteor displayed at Cosford. Now, due to the foreshortening in this photograph, the front cockpit actually looks a lot larger than it is. And before we go off this photo, I'd just like you to take note of the location of the nose wheel there and the fairing for the nose wheel, because that'll feature in our story a bit further on. So to understand why the Prone Meteor was conceived, we need to understand a little bit about the effect of G in aviation. Now, if I'm standing on the Earth here, or very close to it as I am now, I'm experiencing 1G. But as we all know, a pilot manoeuvring in an aircraft can experience far more than 1G. So for example, if we're doing a 60-degree bank turn at constant airspeed and altitude, we're going to be experiencing a force of plus 2G.
I'm getting a little bit of grey out, I can't quite see.
Now, the problem from the human being's point of view is that our bodies don't have an unlimited ability to withstand G. And if we expose our body to excessive G, the excessive positive G in particular, the blood drains away from the brain into the lower extremities. And a typical individual can withstand about 6G unaided, and we'll talk about the aids a little bit later. But the problem is twofold. First of all, people start to grey out typically at about 4G. So they start to get tunnel vision, and a certain amount of their decision-making ability, for example, recedes. And then maybe at 6G or thereabouts, depending on the individual, they black out. Now you might think, well, okay, the pilot's pulling 6G, he blacks out, or she, automatically lets go of the control column, the G come off, and everything then should be all right. But the problem is the poor old heart's working overtime because the blood is drained from the brain down through the body, and it takes some time for the heart to pump back to the brain. So it's not an instantaneous recovery, and therefore in a combat situation where you're most likely to be pulling high G, it's not something that you really want. To have your brain function impeded while your body gets back into some kind of equilibrium. So the term used is G-Loc, which is G-force induced loss of consciousness. And for a pilot seated upright, that typically comes about at about plus 6G. So even during World War II, aircraft were increasingly able to pull high G. So the Spitfire was stressed for just over 6G, and in fact you could pull enough G in a Spitfire to black yourself out. And in the early models, you might even pull the tail off before you blacked yourself out. Now later on, modifications were made structurally to overcome that, but the initial modification that was done in the field was what was called a bob weight modification. Now that was done in the elevator circuit, and it included a weight so that as G came on, the effect of the weight would be to oppose your force in pulling back on the stick. And in fact, before that was done, quite a number of Spitfires of early marks were lost in inexplicable circumstances when the tails came off. Now, if we're looking at a modern fighter aircraft, say the F-16, now I say modern, I mean that aircraft's been around since 1980 or thereabouts, but it's still in wide use. An aircraft like that can pull 9G. So clearly no pilot could withstand that sort of G-force. So the Prone Meteor was designed to look at the possibility of removing or at least alleviating the effect of G by lying the pilot down. Now, you obviously can't lie the pilot down face up because he's sitting there looking at the sky and he can't see where he's going or where anybody else is. So the only option if you're going to lie the pilot down is face down or prone, hence the term Prone Meteor. So that was designed with that in mind, and the designers felt that a secondary benefit too might be that you could reduce the frontal area of the aircraft by reducing the size of the cockpit canopy and therefore reduce drag and perhaps gain some airspeed through that. Now, here's a list, and I'm not going to call it an exhaustive list, of some of the factors at least that affect the personal G limit of an individual. So as I said earlier, some people are better at withstanding the effects of G than others. So that's just something that you're born with or not. One other factor that helps is if you recline the seating position slightly so that you're not flat on your back, but at least you're lying back a bit, and you raise the rudder pedal so that you're in a more sort of horizontal attitude. Now, you may recognise the Focke-Wulf 190 here. These were introduced by the Luftwaffe in the middle of 1942, and a certain Oberleutnant Arnim Faber was engaged in aerial combat over the Bristol Channel in the southwest of England in June of 1942, and unaccountably he became disoriented, and instead of flying back to France and landing at one of the Luftwaffe bases there, he landed at RAF Pembrey in South Wales, taxied in. Now I say unaccountably because I simply can't believe how this could happen, but nonetheless it did. So the quick-thinking station commander rushed out to the aircraft, grabbing the only weapon that he could find, which was a flare pistol, and arrested Faber and took charge of the aircraft. So that gave the British a wonderful opportunity to evaluate the FW-190 virtually at the beginning of its service career, because even then it was giving a really hard time to the Spitfire Mark V's, which was the latest model that the British had available. So the British, and I'm sure the Americans too, evaluated the aircraft, were very impressed by it, but one thing they noticed was that it had a semi-reclined seating position with relatively high set rudder pedals, and they were convinced that this gave a significant advantage to the pilot in terms of resisting the G-force in manoeuvres. Now, there's a bit of a sting in the tail when it comes to Arnim Faber, because again, unaccountably, he managed to convince the British authorities that he had epilepsy. So evidently taking pity on him, They repatriated him to Germany in 1944, only to find that he went straight back into combat and started shooting British pilots down. So how it was that a pilot or a person with epilepsy could ever be taken on board as a pilot is just a mystery. Now, this particular aircraft was the one at Cosford, and I've spent many an hour when I was there studying this aeroplane. It's an absolute masterpiece of brutish engineering and effectiveness. It was just a wonderful machine to go to war in. Now, the third characteristic I want to mention that might help you to reduce or minimise the effects of G in manoeuvres is if you have no legs. Now, I can hear you saying, well, that probably isn't on the selection criteria for most fighter pilots. But there was a very famous gentleman whom many of you will know of. Some of you might even have met him, Group Captain Sir Douglas Bader. Now, he had practically every war-related decoration known to man, plus a couple of others. He didn't get a Victoria Cross, but he did get the Croix de Guerre, and also the French gave him the Chevalier de la Légion d'Honneur, which is the highest French military decoration. And I'd direct you to that rather poignant photograph on the right there, because that just shows you how much or how little of Bader's lower extremities were left after an incident which I'll describe in a moment. Bader joined the Royal Air Force in 1928, and he was doing well, rising up through the ranks. Then in 1931, evidently somebody dared him to do low-level aerobatics in a Bristol Bulldog. Now, the Bulldog had a reputation as being heavy and a bit unresponsive, and he was doing slow rolls, very low altitude, caught a wingtip, speared in, and had quite a bad crash as a result. And as you can see, picture's worth 1,000 words there. The doctors amputated his left leg just below the knee and his right leg at some point up the thigh. So looking at the left shot there, you can see that he had to develop this semi-acrobatic manoeuvre using his right hand to lift his rather useless right leg up over the coaming into the cockpit so that he could get into the aeroplane. Now, this aircraft that he's in is a Spitfire, as you can tell. It's got his initials in the registration number, and not unnaturally his call sign in the air was Dog's Body. But he also flew Hurricanes with 242 Squadron in particular, and Hurricanes don't have that kind of trapdoor thing. So I'd imagine it must have been quite a bit harder for him to get into a Hurricane. But nonetheless, he was an amazing man. He first saw combat in May of 1940 when he was flying top cover for the Dunkirk evacuation. He flew in the Battle of Britain, and he was eventually lost over France in August of 1941. So he had actually quite a short combat career, but during that time, of course, he was lost and captured, and despite numerous attempts to escape, he spent the remainder of the war in captivity. Now, during that relatively short period, he scored 22 aerial victories, a number of probables and a number of aircraft damaged, but he also became known as a brilliant strategist and tactician in how to fight the air war. Now, he was very controversial in some of his thinking about that, but nonetheless, he became very well known for that. And the connection here is that he was absolutely convinced that his lack of lower extremities gave him a big advantage in combat because the blood didn't have anywhere really to flow to as it would in a normal person. So here's a side shot of the Prone Meteor, and I must say when I look at this photo it reminds me of some big parasitic bug about to inject something unpleasant into its prey. And the other thing that concerns me about this is the way the pilot in the front there is kind of trussed up. It doesn't look like somewhere that would be particularly easy to escape from, and as we'll see in a moment, it certainly wasn't. But nonetheless, an emergency egress procedure had to be developed. Now here's a shot of the poor pilot in the front cockpit there, and it may be my imagination, but he looks a little bit tense and apprehensive. And I think the reason for that is that before he takes off, he's contemplating how he's going to get out of this aircraft if he has an in-flight emergency. So the boffins did a great job of coming up with a procedure for people to do that. So let's have a look at it. Now, I have a theory about this. And my theory is that the engineer who was tasked to design this emergency egress procedure kept chickens at his home. And one day he was watching his chickens and he saw one lay an egg, and the light came on and he thought, this is the way that we're going to get out of the Prone Meteor. So we start off bearing in mind that you're only going to do this in an emergency, so you're going to be trying to do it very quickly. You've got to stow the rudder pedals first so you don't catch on them on the way out. You've got to retract the nose wheel, because as you recall from that earlier shot, if you don't retract the nose wheel and you get out through this slide thing, you're going to end up wrapped around it like a piece of bunting. So not really what you want. If there's a ventral fuel tank fitted, you've got to jettison that. You've got to undo your harness, unplug your oxygen lead, and undo your microphone and the other electrical cords. You've got to open the hatch, wriggle back, and slide out. Now, hopefully you can do all that in less time than it takes to describe it, because otherwise whatever emergency you had is probably going to have run its course, let's say. Now, fortunately, this procedure was never used, never had to be used, and the Prone Meteor was never flown solo from the front cockpit. So there was always a safety pilot there. Now, the safety pilot had his nice Martin Baker ejection seat, and he didn't really have a worry in the world. He could punch out of the aeroplane if he needed to, except as long as he didn't mind being reduced to a height of about 4 feet after a few ejections. So I'll come in a moment to why I believe this aircraft was never flown solo from the front cockpit. So the principle wasn't proceeded with because there are a couple of advantages, albeit quite slight, but the disadvantages outweighed them dramatically. Now, I've sat in the cockpit of the Prone Meteor at Cosford, or laid in it, more to the point, and it's a really very claustrophobic and uncomfortable place to be. You've got a very small instrument panel in front of you with the basic instruments. You can kind of see out over the top, but you really get very poor visibility, except other than straight ahead. Your visibility to the side or up above you is non-existent virtually. And the more important thing about it from the point of view of making this the main cockpit was that because the cockpit is so cramped, there's really not room for all the ancillary controls, the gauges, the switches, the circuit breakers that you need in order to fly the aeroplane and operate all its systems. So in fact, if you were lying down, a lot of that stuff would actually be behind you and you couldn't see it anyway. So uncomfortable and fatiguing to fly, but also near impossible to escape from in an emergency. I can understand why they never tried that system out. Now, the better solution is the G-suit or the pressure suit. Now, these were actually around in the 1940s, but they weren't developed into a practical device until much later. So what we have here is a snug fitting flight suit with air inflatable bladders along the arms, legs and torso. And those bladders are associated with lacing, which you can see along either side of the torso there. And with the onset of G, those bladders inflate very quickly and they tighten up the suit even further over the arms, legs and torso and prevent blood from flowing out of the brain area. Now you'll notice I've put a yellow arrow there pointing to something in the centre. I've got an admission to make. That's not strictly part of the suit, but I thought for completeness I'd add that in. Now, does anybody recognise this person? Who?
Gary Powers.
Yes, Francis Gary Powers. Well done. Now, his name is always connected with the U-2 spy plane, which is shown behind him, because he was famously shot down by a ground-to-air missile over the USSR in 1960. Now, these pilots were provided a means of ending their own life, but Francis Gary Powers chose not to do that and angered his American masters no end by his failure to do that, because he was captured alive and intact and put on a show trial which was globally publicised, and he caused the Americans a great deal of anguish. So eventually in 1962 he was repatriated to the US with a spy swap. I think a couple of Russian spies were sent back and he was sent over. So quite a famous man. Now, that's the end of this bit, but I have a question for you. Why do radial engines always have an odd number of cylinders per bank? Exactly, well done. So in a 9-cylinder engine like this, it would fire 1, 3, 5, 7, 9. It'd skip 1 and go 2, 4, 6, 8, skip 9 and go back to 1 again. Very well done. I didn't think anybody would know that, but I obviously underestimated. So that's great. Now, I was very lucky. As you know, I volunteered at the RAF Museum Cosford in Shropshire in the UK for nearly 3 years, not that long ago. And as I mentioned, our first task was working on the Prone Meteor. Now, the Prone Meteor, or the Meteor in general, has probably a total of about 80 access panels. In fact, the aeroplane looks like a patchwork quilt. Now, a lot of these access panels hadn't been disturbed for a long time, so we were tasked to remove them, make sure that the fasteners were not corroded, clean them up and put anti-seize grease and then put them back. So these fasteners are typically countersunk machine screws, and they go into a captive nut on the inside. So at times these fasteners were extremely tight, and we had to resort to the old style bib and brace drill with a spade bit in the end of it, and the two of us would work on it. One would be pushing with all his might so that the bit would go hard against the screw, and the other one would be turning it, and that way we managed to get them all undone. Now, another major job that we did was to replace the canopy hinge seal on the prone cockpit canopy. Now, this canopy wasn't intended to be jettisoned. It's hinged on the right-hand side. You can see the wonderful TSR2 behind it there. This is in the test and experimental hangar in Cosford. So the seal itself ended up, by the time we got to it, in rather poor condition. The prone cockpit is not pressurised, unlike the main cockpit, so it's got a very simple sealing system. And I think what happened here was just fatigue of that rubber membrane with repeated opening and closing of the cockpit. But also, as the seal degraded, the slipstream would start to get in the front and kind of nibble away at it. So by the time we were tasked to fix this, it was in quite poor shape. So this is how the seal is attached there. You can see at the top, the seal is sandwiched between two strips of aluminium that are riveted together. The innermost strip is an inverted J shape that engages into a groove in the side of the base of the canopy, and then in turn it's held into place by machine screws at intervals. Then at the bottom, the membrane is just trapped underneath a strip of aluminium, and there are machine screws there to hold it in place. So here we are hole punching the new seal, and you can see the two strips on the right there, the two aluminium strips. Now we've got the new seal with the attachment strip riveted into place, and we've now offered the seal up, but we haven't trimmed the material, and we also haven't refinished the riveted section at the top there to get a nice smooth finish. And finally, we've got the seal in position. We've just got to do a bit of fettling, clean up those rivet lines, and then we're done. So a very satisfying project that was for the time I worked on it. So look, that's me for today. Thank you very much. Questions or comments?
You mentioned that most pilots could stand 6 Gs sitting. How much can you go up to with a G suit on?
7. Very good point. I didn't mention that. So all the trouble that people go to organise a G suit and measure you up for it and put you in it, it only adds about 1 G to your ability to resist. And even that requires you to tense up all those muscles very tightly to help the G suit do its job. So thank you for mentioning that. Yes?
How many of these were ever produced?
There was only one Prone Meteor made. They did about a year of testing. They did 99 flights of 55 hours in it. But they just realised that it wasn't going to fly in either sense.
We noticed when I did a vampire conversion that the age was a factor. The younger pilots had better resistance than the older instructor.
Yes. Yeah, well that was probably an advantage for the students then, wasn't it? Because the instructor was going to stop talking to them before the student went unconscious. Thanks very much.